the founder and CEO of Ecosistema, a small engineering company based in Italy. And today we'll present the SaferPLACES platform. It's a dedicated cloud web service for modeling and mapping fluvial, and coastal flood risk in urban area. Before presenting the live demo, if I have time, I will just give an overview about the SaferPLACES project and the intelligence behind and the purpose of the platform. So SaferPLACES project has been founded by IT Climate Kick, and the project started in July 2018 and it will last the next year. The project is coordinated by Ecosistema, and the consortium is composed by several partners. We have 2 research centers, CMCC and GFZ, 2 universities, Bologna and Madrid, and other 2 SME, MIO and Humer Consulting from Austria. We have also on board a panel of potential end user and stakeholder, including insurance company, administration and cities, multi-utility company, and also emergency authorities. So the topic addressed by SaferPLACES is related to flood hazard and damage assessment in urban areas. Our cities nowadays are flooding with the increased occurrence, in particular due to more severe weather events, but also due to anthropogenic pressure like soil sealing and subsidence. In this summer, we had several dramatic flood events affecting cities and urban areas from Asia to Europe. And SaferPLACES aims to contribute in promoting climate flood resilience in our city and innovation in the field of urban flood-proofing tools and data. In particular, we aim in filling the existing gap between, for example, urban planners and mathematical models, tools, and data requested for supporting adaptation and mitigation plan in cities, and also for supporting urban regeneration project and the design of nature-based solution. From our perspective, there is a need of new resource-effective tools able to, for example, run in real-time multiple scenario, historical and with the climate change projection, for example, in order to support resilience and adaptation in our cities. And there is also the need that a sort of democratization of these available tools, they should be extended to a wider audience in order to promote the resilience in our city. SaferPLACES aim to address flood climate impacts in cities by developing a brand new cloud web platform tailored for mapping and assessing flood hazard and damages and financial losses in urban area. And the cloud web mapping has been developed following 3 pillars. The first one is research-based. So we have developed innovative and resource-effective pluvial, and coastal flood hazard and damage model. Secondly, we exploited the increased availability of open data, in particular geospatial and climate data made available by Copernicus initiative and platforms. And finally, we started developing the platform with a following a co-design, a co-development process in tight connection with end users, in particular with the 3 pilot cities that has been selected. One is Rimini in Italy, Pamplona in Spain, and Cologne. So this is the framework of the platform, or the components has been developed within a cloud computing framework. In particular, we exploited the Amazon cloud computing power. All the data collected from several sources, Copernicus, Oasis, has been uploaded in the geospatial database on the cloud. And the main core element of the service is represented by the hazard and damage models that has been embedded in the platform. Finally, the web mapping server provides the graphical user interface for the interaction and the visualization of the output with the users. So the platform has been co-designed with several end users, in particular has been designed together with cities, urban planner, and local community that are interested in supporting mitigation adaptation plan in cities or regeneration urban plans. Also with the multi-utility companies that are interested in managing the sewage system during heavy storm weather events. Insurance and reinsurance companies that are interested to have high resolution data for risk profiling, real estate for development of financial assets, investment, and also civil protection and the first emergency agency. So the main characteristics of the platform are to provide quick, cost-effective flood hazard damage assessment calculation for urban environments, able to simulate both current and future climate, and also the possibility to test climate adaptation measures against potential floods, and hold us for the calculation of financial damages and also proceed in simplified cost-benefit analysis. So the intelligence behind the SaferPLACES is represented by flood hazard models. We have developed simplified the computational efficient raster-based flood hazard models, and we have developed 3 dedicated code models. The first one is Safer Rain, is a dedicated raster-based model for pluvial flooding. The code has been recently published in a peer-reviewed journal by Samela, and we got also the monthly cover of the water journal. Then we have Safer Coast. Safer Coast is a fast region growing algorithm. Is a bathtub approach developed in Python. And finally, we have Safer River. Is an artificial intelligence-based binary classification algorithm able to map flood-prone area exploiting the GFI, the Geomorphic Flood Index. Concerning the part related to the damage assessment, we have developed together with GFZ Safer Damage. Safer Damage is a particular type of Bayesian network model. Is an advancement with respect to the classical depth damage function, because it's able to include multiple variables in the estimation of loss. So not only the water depth. The model has been validated comparing observed and model data, and exposure for both commercial and residential are based on a new method of estimating useful floor space of individual buildings from the available open data, for example, OpenStreetMap. Finally, the third element is represented by mitigation measures. So the user has the possibility to test and assess the effect in terms of flood hazard reduction of damages and hazard of several mitigation measures, for example, measures related to flood hazard protection, barriers like artificial dunes, leaves, or also the implementation of sustainable drainage system like infiltration ponds, green area, permanent paving, and green roof. On the other side, we have also dedicated mitigation measures for buildings in order to reduce the damages, the magnitude of the damages. So, for example, building dry and wet proofing, flood barriers, vertical evacuation assets, and other kind of mitigation measures. So before starting the live demo, I would like just to introduce one of the case studies that has been developed and embedded and implemented inside the web platform. The first case is the Rimini pilot, Safe Rimini. The idea is to support the local administration in design urban regeneration plan that consists in a new sea promenade. In this new sea promenade, the main is located along the coastline. So the most important work of this project, that is called Parco del Mare, consists in a building, in a design of an artificial dune with an increase of the ground level of 1 meter, reaching the elevation of 2.85 meters above the mean sea level. And this new dune will be extended along the entire south area of the seafront. And we have also another design work that, together with the Parco del Mare, and it consists in a sort of renaturalization of this important part of the sea promenade, removing the street, the pavement with the green areas. I will invite you to attend at 11 the presentation of Jaro Misiak from CMCC. He will provide you more details about risk assessment in this area. And now, with this 4 minutes, I would like to share with you a live demo of the platform. So this is the platform that is available online. I will give you the address later. So the platform consists in you have a web mapping environment on the right. The user has a possibility to zoom in, zoom out, the classical mapping environment. And then you have a list of tasks pane that are dedicated for generating the scenario. The most important is the search scenario. The user has the possibility to define multiple rainfall, river, and coastal scenario. It can simulate both historical but also climate change projection. So, for example, for rainfall, you can detect from the database the return time 50 years, the duration of the rainfall automatically has the possibility to define the intensity. It can even change automatically with direct input the intensity of the rainfall. He has the possibility to add multiple scenario, and also you can check this button in order to take into account the infiltration. Once he has defined the scenario, you can send the simulation to the control panel and run the job. The same for the river. You can select the return time and running the scenario, and for the coast, you can generate other scenario. So I will not run now the simulation, but the simulation, as you can see, can take 1 minute, and the system will compute both flood hazard and damage assessment. So just 1 minute or 1.5 minutes for this pilot Rimini case studies. The results are available online. So in the hazard panel, the user can select different scenario with different orography. So all the model exploit the high resolution data made available by LiDAR in all the pilots. In this case, we have implemented the Parco del Mare simulation scenario and the actual scenario. So the user can, in the layer, have a look about which are the actual condition. So this is the scenario of 2.77 meter related to return time 100 year in a climate scenario of RCP 8.5. You can see that the system provides high resolution results, and also the damage that are here are computed building by building. So the user can retrieve with this button, the identify button, we can retrieve the water depth. I can retrieve also the value of damage in euro. The same simulation has been computed considering the scenario of the implementation of the Parco del Mare with the dune. So this is the P Mare, and you can see that along the south side of the coastline, the effect of the dune will reduce completely the flooding of the rest of the city. We have only the flood of the area nearby the coastline, and again you can visualize the damages that are only now located in the north part of the city. In another, if I have time, yes, I have more minutes.
2 minutes.
Yeah, not actually not all the function has been implemented. We have a video of new dedicated function that we are embedding. This function, for example, permits the design of specific mitigation measures. In this case, we are able to draw directly in the web platform a sort of barrier and define, for example, the same barrier that has been implemented in the Parco del Mare. We can define the elevation and running the simulation considering the new orography and the presence of the barrier. Another kind of function related to mitigation is related to the application of mitigation measures to different buildings. So again, the system, the platform will be provide to the user the possibility to select building by building. No, this is the land use, sorry. So this is another mitigation measures related to the land use. So the user can change land use, for example, change the type of soil, select rainwater detention park, or defining green areas that has different infiltration parameters, and so they will have a mitigation effect, for example, for pluvial events.
Can you conclude?
Yes. Last slide is this one. So if you are interested, please, you can access to the platform that is available at platform.saferplaces.co. There is also a video tutorial. You can log in and ask specific, you can register yourself and ask the grants to access to the platform. So the 21st of September, we have a dedicated webinar organized by Oasis. So if you are interested, we have more time to display all the function and describe all the potential of the platform. Thank you. And if you have some question, I'm here to answer.
Thank you, Stefano. Looks very interesting and nice what you developed. Does anyone of the audience have questions? I don't see anyone unmuting his mic yet. I do have a question. So you showed the selection of the scenarios. Can you make a combined scenario where you do have a storm surge combined with a high river level combined with high intensity rain, or are those separate things?
Yes, actually, so far in this version are simulated as separate version, but we can easily add this function and combining the water map and then computing the damages considering a combined scenario. So this is something that possible that we have in plan to develop in the next phase. We have another year of development of the platform, so I think this is something that is in to-do list. It will be possible, definitely.
Yeah, I think it would be very beneficial because there's, at least in the Netherlands, it's the case that high sea levels through storm surge often are combined with rain and bad weather. So I guess it will be a really useful contribution.
Yes.
Anyone else having more questions for Stefano? It doesn't look like it.
Thank you.